Hello, we are Team KFC.
Now the scenario. You and some friends are sitting in your den watching TV and playing pool. The body heat from all the excitement is raising the temperature of the room and thus kicks the thermostat on. Well, after a while, your friends leave and you decide to head upstairs to relax. Unfortunately, you're freezing now. This is because while the thermostat was reading elevated temperatures, this was only accurate in that single room. Rather than walk all the way down to adjust for compensation, you simply turn on the GTE remote, thus compensating for you.
This unit is the base unit. It replaces the unit on your wall now. The microprocessor is the brains behind this unit. It adjusts the temperature through the temperature control routine. The relays receive a signal from the microprocessor and then relay it to the HVAC system. These signals are heat, fan, and AC. The user is able to adjust settings on the thermostat using a resistive touchscreen. He is able to adjust the mode, fan, and temperature set point. The user is able to confirm these settings using the LCD screen. On the top left is the mode setting, the bottom left, fan, middle, remote status, top right, temperature set point, bottom right, actual temperature, which is controlled by the base sensor. This is the remote. On the remote, we have a battery pack consisting of 4 AA batteries. After vigorous testing, we have achieved over 30 days of use. On the remote also is an on-off switch. On both the remote and base unit are XBee transceivers. These transceivers are used to communicate with each other. We were able to establish communication using a program called XCTU. Here are some various settings we used. This is communication between the remote unit and base unit. When the remote unit sends back a string of data, we're only concerned with the few pieces, as highlighted here. In this second communication, we are still only concerned with the same pieces of data, again, as highlighted here. Programming was achieved through the Arduino development environment, which is based on C, C++. Here is some sample code from our previous revision to demonstrate how the environment works. The first highlight of our code is the use of the EEPROM. In case of power failure, all settings will be restored upon the return of power. The next piece of useful code is how we put the remote to sleep. As temperature change is gradual, we didn't need to continuously send data back. Instead, we sample every so often and then put the remote to sleep, thus extending battery life. After the code has been compiled, it will display how much data has been used and how much data is available. On our final version, we use only about 40%, leaving room for expansion. Now is the COM window. This COM window greatly allowed us to troubleshoot any errors that arose by displaying the bits of data that was passing through the microprocessor. This is revision 19, our latest and last revision. Due to the inaccuracy of the temperature sensors and the always changing readings we were receiving even at constant room temperature, we implemented a routine that sends a burst of 5 readings over during transmission. The unit looks to see if the previously recorded temperature is among them, and if so, keeps the same temperature or adjusts accordingly. Here are the test rigs we used to simulate the conditions. Here are some of the results that we achieved.